Working Group 3 within the Engineering and Sustainability Committee at IALA. Alan will join us tomorrow. And thank you to Ronan for stepping in to help out on chairing later on today. Jaime, do you have any administrative things to start off with before we get moving on the program?
Yes, I have just started the recording. Same will be posted in the IALA event website as well with all the presentations. And please, I want to remind you to turn off your camera and mute your microphone if you are not talking and in the camera. Thank you.
Thank you, Jaime. Yes, everybody is being very courteous and polite today, so thank you for that. So without further ado, I will hand over to Francis Zacharias, Secretary General from IALA. Francis, if you could formally open the workshop, please. Thank you.
Thank you very much, Simon. And on behalf of the Secretariat and myself, of course, I would like to welcome you all to this workshop on enhanced radar positioning system. We are, of course, again, very disappointed that it is another virtual event because we have postponed and rescheduled all our workshops and events many times in order to be sure that it could be a physical one. But as you know, the pandemic is still, or can I say, again, a problem. But we really hope that next year, all the events can be in person here in Paris, or of course elsewhere in the world as we are used to. I think we really need that, and we certainly miss you all. And we are absolutely convinced here in IALA that face-to-face meetings are the preferred option. First of all, I would like to thank all the people who have been involved in this workshop. The chair, Simon Milliard, thank you very much, Simon, and all the working group chairs, speakers, and you, the participants. I would say an amazing group of specialists and experts, and I really look forward to learning more about this, may I say, very complicated and important project. We have always tried to identify threats to our maritime services. This is not a new thing. It could be weather, climate, visibility, etc. But in an increasingly connected and technologically dependent world, new areas of vulnerability are emerging. Only a week ago, we hosted a workshop on cybersecurity here in IALA, and the two workshops are very much related. They both deal with our vulnerability to intentional or unintentional hacking, jamming, spoofing, and such like. This is, of course, the price of being more and more digital and connected, and a price that we are willing to accept, but we need to be well prepared and also protected. It is now generally accepted that GNSS is and will be the primary position and timing sensor for maritime navigation. But as we all know, there's a strong need for alternative resilient systems. True resiliency will only be achieved by the use of complementary dissimilar systems, such as radar or low frequency, high power terrestrial systems, or autonomous onboard alternatives, such as inertial sensors, etc. And this is exactly the purpose of this workshop, to learn more about ERPS, which has been proven in trials around the world, and which uses an enhanced radar and enhanced recon to provide a vessel with position which is independent of GNSS and offers the maritime a true resilient alternative. More specifically, it is the hope that this workshop will draft outlines for each standard identified during the workshop, and also draft liaison notes, that is what we use in IALA, a liaison note, to each organization that has been identified for each of the proposed standards, requesting that the draft standards be added to their agendas. And of course, it will also be the task to propose a roadmap and a timeline. Might be difficult, but again, very, very important. All this will be input to the engineering committee and incorporated in their work plan for the future. I'm not an expert in this area, and I really, really look forward to the outcome of the workshop, especially to understand the project and possibilities better and how our committees can better take this into account in the future work for the benefit of the maritime community. Once again, I send my thanks for the continued dedication of those who plan and attend this coming week, for the time you give to ensure that the committees can work more efficiently with this very important solution to the need of resilient P&T. With this, I wish you very good luck with your very important work this week. Thank you very much, Simon.
Francis, thank you for that introduction and the support we have from IALA for this interesting technical topic. And this is the start of probably a long journey, but a very interesting start too. So thank you.
Absolutely. Thank you, Simon.
Jaime, could you put the technical program up, please, on the screen? So in a moment we'll see the here we have it. Thank you very much. Thank you. So this is the plan for the day. We will we have a 3-hour session, and at around 11:50 we will have a 10-minute break for a cup of tea or a cup of coffee, or hot chocolate, depending upon where you are in your time zone. And we're now going to hand over to Paul Muller from Half Pi in America, and Paul has been instrumental in the commencing and the monitoring of this technology in his former roles, and is really interested in and has done a lot of work in putting this workshop together. So a big thank you to Paul, and I think Paul, it's time for you to start your presentation on the program for the week, and then run straight into the drivers for this. Paul.
Great. Thank you, Simon. Thank you, Francis, for stealing one of my presentations. I hope you all remembered what he said, because I'm going to be saying the same thing in just a few minutes. But Francis did a very good job of explaining what we're here to do today. You've seen the program on the screen there. I'm going to now try to take over the screen myself. And how do I do that?
Press the open share tray, the arrow in a box.
Ah, okay. And I can share. Okay. Are we sharing? I'm sorry, I can't see.
No, we're not, Paul. You need to press the open share tray, pick your screen, and then press share on that screen.
Okay, this slideshow is not working correctly.
If that doesn't work, we can have Jaime run the presentation from his
Well,
end.
my problem is I turn on my slideshow, I can't see anything else. So I have no idea what to do.
Okay. Yes,
Not the slideshow.
I have your presentation. If you want, I can share.
Okay, great. Thank you. I'm sorry, everyone. I don't know how to operate the slideshow, apparently. All right, Jaime, please slide 5.
Jaime, did you get that?
Yes, sorry.
Sorry, slide 5, was that?
Yeah.
Slide 5, yes, please. Thank you. Okay, good. What do we intend to accomplish this week? Francis mentioned some about this. What we intend to do is, first off, is to educate the attendees, make you aware of what's been going on, what we're doing, and what we want to do. We're going to give you a justification for why we even started ERPS and why we need it. And identification is where Francis came in, so we need to identify organizations that ought to participate and identify the standards that need to be written. And then we will wrap it all up with a planning exercise that will be our roadmap for what we're going to do in the future, which, as you see in our outputs, the roadmap, the way forward. This is maybe one of the more important things we're going to do today, because it shows to everybody not only our intent, but that we're serious about actually doing something here. I think raising awareness and getting buy-in from all the various parties is going to be our most difficult task. And then we will also have some liaison notes to the organizations identified to invite them to join the ERPS planning and to get on their agendas. We have an idea of who those organizations will be, and we'll discuss those within the workshop. And then we will draft some standards, short descriptions of the standards needed. If we have people who are familiar with the various reporting or requirements for the organizations involved, excuse me, we may wish to draft these cover sheets in the language that the organization would prefer. Hopefully we have some people here who can help us with that. And then what happens next? Well, IALA will take the outputs. An engineering meeting in March, we will go through those outputs, we will clean them up, we will finalize the liaison notes and send them out to where they need to go. And we will start to put the draft standards into the form needed for the organizations. That may take some time. I don't expect we'll get that all done within one session or even 2 sessions. We may have some intersessional meetings in the meantime to work out some of these standards. Once the organizations take them up, they're no longer our standards, but I believe we ought to continue to participate. And I guess we will see what happens there. Next slide, please. Driver, why are we doing this? Okay, well, next slide, please. IMO identified an area of concern, mostly having to do with jamming of GNSS services, I believe is where it came from. The concern was, how do we live in a world where we're telling everyone to use GNSS, but we can't really support it 100%? It's a good thought. And so, as part of the e-navigation program, they added, for instance, this paragraph to their e-navigation strategy and suggested that service providers provide services that would aid in working around problems with GNSS. So we get terms like redundancy, robust, reliable, dependable, resilient. Here's a good one, resilient. Then the implementation plan itself, as one of the risks, improved reliability and resilience of onboard PNT systems. All right, now how are we going to do that? GNSS is all pervasive. There is, in most areas of the world, no substitute for GNSS. If you have GNSS where you have eyeballs. You have to look it up. You have to watch the stars, things like that. Some areas of the world, LORAN is still operating. That can be used, of course, if GNSS failed. Other parts of the world, there's, like I said, nothing else. So how do we take care of this problem? Now, this last paragraph is very important. To achieve resilience in PNT's position navigation timing service, necessary to put in place a backup or fallback arrangement. Utilizing technique that do not share the failure modes of GNSS. In other words, they're lumping all of the GNSS into one category here, and because they're all in the same frequency, they all use similar signals. They're all subject to the same failure mechanisms, and they're asking quite plainly for an alternative to GNSS. Okay, next slide, please. ERPS fits in. All right, now ERPS, I will be going over the history of ERPS in the presentation in a few minutes. But it was basically brought to the attention of IALA by Jens Jensen, who was at the Danish Maritime Academy, or administration, excuse me, at the time. I believe he had presented the same papers to eNavigation underway 2 months before the IALA meeting, the eNavigation meeting he presented at. And he proposed this system as an alternative to GNSS, the ERPS system. So we'll go into that further in a few minutes. Now, for now, IALA documents have been including things like resilience and standby and backup and all these various terms for years now. As you can see, the one recommendation, R129, has been around. Well, that's the edition 3.1. It's been around longer than 2012, and it's been saying similar things since then. GNSS vulnerability. That's the big issue. How do you mitigate GNSS vulnerabilities when the only receiver on your ship is GNSS? What do you do? And in recommendation 1017, this is not a technical recommendation. This is more of a management statement, is that IALA will try to provide resilient position, navigation, and timing to its users. Well, IALA will provide assistance to the ancient navigation authorities who aren't the users. It's the mariners who are the users. And that's where this management comes in, is to ensure that IALA members take into consideration that GNSS is not secure, is easily upset, and we need to do something about this. As an interesting side note, even the Federal Aviation Administration in the United States says that GNSS is not completely safe for navigation purposes for aircraft in some parts of North America. That can probably tell you an awful lot about how bad or how dangerous the situation is with interruption of GNSS services. That the FAA says don't rely on it, use other methods as well. In terms for aircraft, they do a lot of looking out the window apparently. The other choice they have is VHF direction finder. So even those aren't very available anymore. They've been taken apart because GNSS appeared to work so well. Okay, let's see, what's next? ERPS fits in. All right, so you may also hear some conversation in the next few days about AIS and how AIS fits into this. AIS is a completely different thing. AIS will not tell the vessel where the vessel is. There's no way to get that information from AIS. AIS can only tell you where it thinks the targets are. Keep in mind that AIS is totally dependent on GNSS. With no GNSS, there is no AIS. So AIS cannot be considered to be any kind of a backup system in terms of resilient PNT. All right, so please keep that in mind. I'm sure the question will come up, and that's basically what the answer is to that question. All right, so Jaime, I'm done here. If anyone has any questions, we can probably take some questions right now.
Thank you, Paul. Any questions from Paul at this stage on the drivers for and what we're looking for in the week? Any questions here? Okay, then thank you very much, Paul. That set the scene nicely, and so we'll move on now. We're going to look at the general view on the ERPS concept, and we're going to hand over to Guillaume Martin from AMG Microwave. Guillaume is a second-year PhD student looking into the new generation of Raycons. So absolutely right on this field. This is we're very fortunate to have Guillaume with us today. So Guillaume, if you could take the screen, if you can. If not, we can use.
Yeah, I tried.
How is it there?
Is it good?
Excellent. Over to you. Thank you.
Thank you. So first, I want to say I'm pleased and honored to be one of the speakers to this opening plenary. It's lucky for me. It's right on my PhD thesis subject. So first, I will start by recontextualize the use of ERPS. Then I will describe what is an ERPS, and finally, I will detail how it may work. So, as it has been said earlier, GNSS is a primary source of positioning. It can be used to localize targets with high precision, and with augmentation, it can provide positioning down to the meter. So as a consequence, the usage of GNSS has become predominant as a primary position, navigation, and timing data source in many industries, and in the maritime field also. However, the higher the dependence on GNSS, the more critical availability and continuity of service will become. And as it has been said in the presentation, in the ERA presentation, GNSS can be jammed or spoofed, and often without detection by the users. So resilience in PNT service in the maritime field is essential, and the need of a backup or fallback arrangement using alternative techniques that do not share the failure mode as GNSS. So we need to develop a resilient backup system that should include independence from GNSS. The system should have high reliability and high availability. So it's that's where enhanced radar positioning system could be a solution. It is for the moment radar beacons are receiver transmitter operating in the maritime radar frequency bands between in the X band or S band. And the Raycon enhance detection and identification of certain radar targets. So Raycon responds to the presence of a ship's radar by sending a characteristic pulse train. That's what you can see in the middle figure. So the response appears as a coding mark or paint on the ship's radar display that will highlight the range and bearing of the Racon. Racons already, so Racon provides reliable information to vessels, and if the Racon is located as a fixed site, their position is known and will be independent of GNSS. That was for the Racon. So an enhanced radar positioning system will use an enhanced Racon that will announce their location by encoding their identity and position into the response signal returned to radars. So on the radar side, enhanced radars will use this encoded data to calculate the position solutions. So target positions solution may be more accurate than the charted target position. And the ERPS has been under trial for many years, and results have been presented at IALA conferences. And those results will be discussed later in the presentation. So my last slide is how ERPS works. So the Racon position is surveyed and entered as a static parameters in the Racon. Therefore, Racons must be located as fixed sites and not placed on BIOS. The Racon identification and surveyed position data is encoded by the Racon using modulation in the leading dash of the Racon Morse code response. So you have two cases on this slide. In the first case, the radar sees only one Racon, but can use its own true heading to calculate the position solution. And in the second case, there are two Racon, and then the radar can calculate the position solution that is independent of the heading of the vessel. It uses the Pythagoras theorem with target range and to calculate two possible solutions. And the target azimuths are used to discriminate it between the two solutions. So that will be it for me today. Thank you for listening.
Yeah, thank you very much for the introduction there. Any questions there? We have a technical expert here on the online. Any questions for Guillaume? Okay. We have a hand up. Aman, over to you, please.
Good morning to everyone.
Yes, good morning. We can hear you. Yes, please go ahead.
I am Serge from the Caribbean Port Authority. So I have a question regarding the subject. Please, to what extent can the ERP be a backup to a GNS? I will take an example. If a ship is in the middle of the sea, how is it going to use the ERP to calculate its own position? Is it a coastal solution, or is the ship can use it in the middle of the sea to identify its position?
I can answer that, Simon.
Okay, please do.
Hello, Alan. My name is Paul Mueller. You're correct. You cannot use it in the middle of the sea. It is a coastal or harbor approach type of system only.
Okay, thank you, Paul. Yeah, I think sort of it's radar range, radar and Raycon range, possibly 30 miles, I might suggest, but it is not suitable where you can't have a fixed Raycon. So, Sergey, okay with that?
Okay, I'm fine. Thank you.
Thank you. And we have a hand up from, I can't see the name because it just has ERPS workshop, but whoever that is that has your hand up, please go ahead. Perhaps you could introduce yourself.
Hello, sir.
Hello, you're very quiet.
I have some questions. GM said that Recon will send position information to radar, right?
Yes.
Because this ERP system will be independent on the GPS system, right?
Yes.
So
Yes.
Recon cannot send its GPS information to radar.
That is correct.
So what kind of position information that Recon can send to radar? What kind of position information? In another way, because radar can know the range from the reply of Recon, radar can calculate the distance from vessel to Recon, and also know the angle related to the heading direction. So radar can also calculate the position of Recon. So the question is, what kind of information that Recon can send to radar?
Okay, hi, this is Paul again. The Raycon has to be pre-configured with the surveyed location of the Raycon. GPS, GNSS is not used at all in this system. Standard survey methods have to be used to determine the location of the Raycon. That's what allows the ship to be able to calculate its position based on the known position of the Raycons. It's similar to triangulation that would be done with pencil and paper by a navigator. If you know the locations of your targets, you can compute your own location. So what we're doing here is we're just being very obvious about the location of the target. In this case, it's the Raycon. In many cases, especially in busy harbors, it's difficult to determine where your targets are and compare them to the chart. So it's kind of difficult to actually do a calculation when the radar picture has a lot of targets on it. So this system, well, that's why Raycons were invented to start with, was to make targets easier to identify. But this system adds the location of the Raycon to the information that the mariner gets from the Raycon so that the radar can calculate the vessel's position correctly. Does that answer your question, please?
It just as I'm still not quite understand what kind of positioning information that a Recon can send the radar in the Morse code, because Recon send the Morse code to radar, right? And
yes.
Actually, radar can know the position of Recon from the time of the reply of Recon, right?
Yes, we modulate the dash.
Yeah, from the beginning of the dash.
We modulate the beginning of the dash with the information that is being transmitted.
Also, radar know the direction of the Recon.
Yes, it does.
Yes, so radar know the direction of Recon, also know the distance of Recon. So radar can know the Recon's position immediately without any other information that Recon send, right?
Well, that's incorrect because the ship doesn't know its own position.
Yeah. So
yeah. See, this is the assumption of our ERPS system is that the ship does not know its own position. How does it get its position? There's no GNSS. It has no way to find out its position.
Another question is, you see, Recon reply has some delay.
Yes, it does.
Usually the delay is 500 microsecond, right?
Nanoseconds.
And this means about 75 meter.
That's correct.
So if radar calculate Recon's position, radar has to consider this delay.
That's correct, and that's one of the things that needs to be standardized. You've just identified the first item here that needs to be standardized. Is that delay? It has to be the same for every Raycon.
And the different Recon manufactured by different company has different delay.
That's correct, because it is not standardized. They can do whatever they want.
Also, it is said that GM is developing new generation of Recon.
There are always people working on Raycons.
New generation of Recon.
Yeah, I don't know what that means. Maybe it means being able to respond to FMCW radars as opposed to pulse radars. I don't know what that means. Next generation.
So this means that for the new generation of Recon, maybe the reply of the Recon is different.
That's correct. Might be.
So because I see from the ITU website that the United States is recommended to update the Recon technology in order to respond to the new solid state radar.
Yes.
In this case, that how do you say? Now we are talking about current radar is magnetron radar.
Yes.
And the United States is considered the solid state radar.
Yes. This is not a new problem. This is an existing problem with Raycons. There's no standardization for this problem either. It's another thing that we can address at this workshop. Is, not only do the radars and Raycons have to be standardized for how ERPS works, but they also have to be standardized as to how Raycons and radars work, because that's not standardized at all anywhere. There are some recommendations, but they don't have the same weight as standards. So the issue of Raycons working with the newer solid state radars has been an issue for some years. Personally, I've been working on it for almost 20 years now. And that's one of the things that we really do need to discuss at this workshop, is how to maintain that compatibility. That's a very good point. Thank you.
Yeah, so the third question is if we have to also consider the new technology of radar, because the United States already presented this issue to ITU in 2018, 3 years ago already.
Yes. And unfortunately, it's not an ITU issue. ITU can't really do much about it. It has to be done between the manufacturers and the users. What do they want to see? How do they want to see it? The Coast Guard itself is not a user. They're just providing a service. The user is the mariner. What does the mariner want? What does the mariner expect? And that's one of the things that we need to work out at this workshop is what organizations have to be informed about this and which organizations do we feel should be involved in the standardization. These are very good points. Thank you for bringing them up. Yes, we will be considering them at this workshop.
Thank you for taking your
Very
time.
good.
Thank you.
Oh, you had very good arguments. Thank you very much.
Thank you.
Thank you, Paul, for answering that. I've got one question here. You said, Paul, and I don't know whether it be Paul or Guillaume to answer this, that does the RACON have to be registered, or can any eRACON work in its survey position a bit like AIS, or does it have to be registered in the radar first?
It's entirely passive. In other words, the radar does not have to have any pre-knowledge of where the eRACONs are.
Sorry, I thank you for clarifying that. I picked that up on your last. I see a hand from Mario.
Thank you, Simon. Just question from me. My name is Mario Walterfang from the German Waterway and Shipping Administration. Just a short question. Is it intended to use ERPS for X and S-band, or shall it be just a system for X-band? Because IMO, I think in the past, make a decision that S-band RACONs are not obliged to be triggered by radar anymore. So what is your plan for this? Do you include S-band besides the technology, which might be similar or the same, but for standardization purpose, I think it's essential to make the decision whether you go just for X-band radar or also for S-band. Thank you.
Maybe Guillaume, could you answer that? Are you working on just X or as X and S-band?
I think it will probably be on the X-band, since it's the most common used, I think.
Okay. Thank you. Neil, you have your hand up. Neil Slater. Neil Salter.
Good morning, Neil Salter from the United Kingdom Hydrographic Office, ex-mariner. Just a couple of brief points, really. I think the issue regarding the new solid state radar is something of a side issue which we can deal with later. I think the main things that we need to do first are to establish a specification for the station signal at the RACON itself, and a specification for the equipment that's going to receive it. Once we've got those in place, then we can address the issues of how to make sure it's available to both magnetron radar and to the lower powered solid state radar. That's all. Thank you.
Thank you, Neil, for that input. That's interesting. Thank you. Okay, I think time to move on here. And we're back now to Paul, and we're going to look at some trials of RACONs that have taken place around the world, and Paul will give us an overview on that. Paul is well versed in this. He's been in RACONs with tidal and signal for over 29 years and has a wealth of experience. So Paul, over to you. Actually, sorry, I see we have a question from Chris Hargreaves. Chris, do you want to chip in now?
If I could, just before we move on, my understanding of this technology is that the encoding of the RACON's position into its return requires a frequency modulation technique. So it's only available for new technology solid state radar. The return will just look like a pulse to a conventional magnetron radar. They'll see the Morse paint, but they won't see the data. This is my understanding. Perhaps I'm wrong, in which case the system is restricted only to S-band at the moment.
Chris, you're not usually wrong.
If I'm incorrect, then perhaps someone could explain that.
Yeah, Chris, you're not usually wrong, but maybe Paul could just clarify that.
Yes, thank you, Chris. That's a good question. There's no technical reason why a magnetron radar cannot receive these pulses. none at all. It's dependent on the receiver that's being used. If the receiver can be modified to take an encoded or FM modulated message, then a magnetron radar will work with ERPS. The test radar was solid state radar. Well, it was easier to do for the test actually, because the solid state radar already had a software defined radio receiver, whereas most magnetron radars, I'm sure, do not. They might just be very specific to that type of modulation. There's no technical reason why it can't be on S-band and X-band. What you seem to be alluding to is that there aren't any solid-state X-band radars, and that's because there isn't any standardization how they work with Raycons. That's why the Mariner does not have available any X-band solid-state radars. It's my intent to talk about that issue at this workshop, because that's going to hold back everything. You know, it's not only going to hold back traditional Raycons, but it'll hold back ERPS. So I think it does need to be talked about at this meeting to some extent. And then, yeah, of course, getting the over-the-air standards. That should be fairly simple and straightforward. We just have to agree on what kind of modulation we really want to use. At the moment, it's FM because that was easy to do. You know, it's very simple. We made it work very quickly and easily, and we didn't have to make any hardware modifications to the Raycon. Bruno used one of their standard solid-state radars and tuned it for the frequency, and you know, took advantage of the processing capability in their existing radar in order to do this. So, yeah, there's a lot to talk about over the next few days. It's still a big subject. Yes, thank you.
Thank you, Paul, and thank you for that, Chris. Paul, back to you now on looking at some trials that have happened around the world. So, would you like Jaime to take the screen?
Oh, I think I can. I think I have it. Do I have it?
It looks, yes, you have it. We have
All
the
right,
screen.
great.
Over to you.
Okay.
Over to you.
I figured that part out.
Well done.
So, all right, ERPS trials. As I explained earlier, the ERPS system was brought to IALA's attention by Jens Jensen of the Danish Maritime Administration. And we actually had a working demonstration in 6 months from when he showed it to us. Talk about that in a moment. Here you see one of the test radars. This is in Singapore. You see the Raycon on a pole, and you see the radar on the vessel. As I mentioned earlier, this is a solid-state radar. It's made by Bruno. It's not a commercially available radar. I'm not sure where they got it from. It may have been something they've been working on, but it was X-band. They tuned it for this operation, and they did a huge amount of work to run these demonstrations. And I thank them immensely for all of their work. So, we did 4 trials. First one, Denmark in 2011. This one was done 6 months after it was introduced to Thailand, which I think was a remarkable accomplishment by both Bruno and Thailand. That demo actually used amplitude modulation. I'm not sure why we started with amplitude modulation anymore. Then we did a trial in the UK in 2013, and then 2 trials in Singapore, one in 2015, one in 2017. the differences between the UK and Singapore trials is that as we went to the new trial, Bruno tried different techniques for calculating position. They accounted for more error terms, such as the delay between when the radar receives the pulse and starts transmitting, and you know, things like that. So the numbers got better as the trials progressed. We suspect that the results from the 2017 trials are going to be very close to what we're going to expect in an actual unit, or an actual system rather, if we do go forward here and we are able to commercialize this. And here are the results of the trials. Now, Singapore, I have to say, is a very difficult location to do this in because there is a tremendous amount of radar noise. There is a tremendous amount of signal blockages due to vessels and buildings and other structures. In fact, the trial we did in 2015, we had to take the Raycons out of frequency agile mode into a fixed frequency mode in order for the radar and the Raycon to find each other. We were able to work through that, and in Singapore 2017, the Raycons were operating as frequency agile Raycons, which was what they're designed for. You can see the errors here. Best available is probably the column you should be looking at. Best available means either one Raycon or two, or best of two. You can see the availability numbers are much higher than either of the other cases. And the error is quite good. There are a number of error terms that we haven't included in the solution. Those will need to be worked out as part of the standardization. I don't know if I can say anything else about this. It looks quite good. I mean, you look at that. Dynamic is the number you should be looking at. That's the vessel moving through the harbor. 25 meters was the error. You're not going to. That's actually, I believe, around the same order of accuracy as LORAN. And so LORAN is considered to be a backup to GNSS. I think this shows that ERPS can also be a backup to GNSS as long as we're within a region that supports the ERPS system. So here are our conclusions. It's generally good performance. We're very happy. I mean, when the first one worked at all, we were very happy. But this, we managed to improve it. Got very good, actually. Radars in busy harbors are poorly serviced by Raycons in general. Now, this is an ongoing problem. This isn't new with ERPS. This has been here forever. We have always, as a Raycon manufacturer, we have always had complaints that people can't see Raycons in busy harbors. Well, we know why, and we'll talk about that in a moment. All right, so radars in busy harbors. Here's 3 different reasons we came up with. Blocking of signal by other vessels. In other words, it's a physical, the radar just can't go anywhere. There's a physical object blocking the transmission. If the Raycon is busy transmitting, it can't respond to a new radar. That's kind of obvious as well. But those are problems that we can't mitigate. They're there forever. Raycon side lobe suppression issues, including the too many radars at the same frequency problem. Now, this is a problem that IALA has discussed with CIRM. They're the industry group that standardizes radars for marine use. Too many radars at the same frequency. That's something we'll have to discuss during standardization, because with solid state radars, this problem actually gets worse. And in busy harbors, if it's not mitigated in some way, in busy harbors, Raycons will be useless with solid state radars. That's really all I can say about that at the moment. Another conclusion is the modulation that we used on the E-Raycon can be visible on the radar display. Now this is any radar, not just an ERPS radar. The modulation makes the leading Morse code look a little fuzzy on the display. Fuzzy. That's a great term. Someone said that. I can't remember who it was now. Geometry is important. How you sight the radar Raycons is very important as to how much accuracy you're going to get. It's the same problem, horizontal dilution of precision, that you get with GNSS. It's a problem you also get with hand and eye calculation of position. It's just small angles. Very hard to get accurate calculations when you're using small angles. So that's what this is about. It's a geometry problem. The expected additional cost per unit for radars and Raycons is low. All right. The reason why is this equipment already has the receivers necessary to do what they need to do. They already have the transmitters necessary to do what's needed to be done. So what we're talking about is operating them in a slightly different way. The cost of that is all pretty much in development work, but the unit cost to build an E-radar or an E-Raycon is actually very low. And almost no additional cost per unit. And the last conclusion, very important conclusion, is that we believe ERPS is a candidate backup system because of the kinds of accuracies and availability we were getting. We felt that it has merit. It's useful. And it's very useful. Now we need to convince everyone else of that. So that's why we are having this workshop. I want to thank very generous assistance, thankful for the assistance of the Danish Maritime Authority, the General Lighthouse Authorities of the United Kingdom and Ireland, Maritime and Port Authority of Singapore, Bruno Electric and Tideman Signal, for everything they have done to make these trials successful. Okay, that's that. Do we have any questions, please?
Any questions for Paul on the results of the trials? It's all interesting stuff, although we had a good technical few technical questions came in last time. Okay, so moving on to the need for standardization and appointed bodies. Grateful to Pablo Racionero from Faros Marine, who's going to talk to us on this. Pablo has a master's degree in engineering and a comprehensive background in ports engineering and renewable energies, and in recent years has been working with Faros Marine as a principal business development engineer. So Pablo, thank you for joining us. Thank you very much. And we look forward to hearing from you on the need for standardization and the various bodies there. So Pablo, thank you.
Thank you, Simon. Hello, everyone. And let me see if I can share my screen 1 second correctly. I need to do this. Okay. Okay. So I hope you are now all seeing the presentation.
Yes, we can see the screen need for standardization. Thank you.
Okay. Okay. Yes. So, okay. Thank you, everyone. So, yes, I've been working for several years with Faros Marine Automotive Power. We are one of the industrial members in IALA. And yes, we have some experience with Raycons. So, as we have seen on Paul's and TGM presentations, just recapping a little bit, a problem was identified. So there was a requirement from the IMO for redundancy on e-navigation systems. Today, the primary means of positioning is the GNSS. We can imagine that the GPS alone cannot provide robust positioning, and multiple or different GNSS won't provide the resilience that is required. So to implement a new level of resilience, the radar positioning could be a potential solution. We have available the coastal radar beacons, the Raycons, that they have sufficient range, and especially new generation Raycons can easily modulate the signal and include positioning and some level of identification. So the radars within range can demodulate and get the position. So by adding a small functionality, e-radars and e-Raycons have proved that radar positioning is technically feasible. And as we've seen from Paul's presentation, this has now been tested and seems to work okay. So we are now at the time to look for a standard. We have a solution, but we need to verify this solution, ensuring that we satisfy all the problems without creating new ones. So e-Raycons and e-radars must interoperate efficiently with the current systems, norms, and procedures. So now, during this workshop, we are going to try to establish guidelines for e-Raycons and e-radars to interoperatively work and have this framework for utilization of the ERPS. Okay, so what are we looking for? So standards should be our building blocks for complex product developments and these new techniques of positioning. I've got there on the presentation the definition from the International Organization of Standardization. Just remarking that this standard needs to be established by consensus and for common and repeated use. Because what we want, and also seen from the CEN, that this standard should be based on the consolidated results of science, technology, and really important experience, because we want to get an optimum community benefits. We are looking for a coherent system between all parties, allowing interoperability. So as an example, Raycon manufacturers using similar design principles to send position to the radars, and radar manufacturers using similar design principles to decode the message. We need to get a dialogue between the parties to establish a general agreement, because we need safe products with a low level of risk, and most importantly, a reliable system. So the main purpose of the workshop is to identify required standards and key organizations, and to invite those organizations to include the ERPS standards on their agendas, and to set initial roadmap and time frame for standardization. It doesn't look an easy exercise, but we'll try our best. So the standardization committees should consist on experts of potentially all these organizations, creating a good practice on this field. So let me just go to the next slide. Okay. So on this one, I just wanted to mention that it won't be only identifying. It's going to be about team working. So we'll establish working groups that needs to show a balance of interests represented. Those working groups are supposed to meet and make technical decisions on this process, hopefully establishing good working procedures and understanding and respecting diverse points of view. Individuals and corporations in working groups needs to have a balance of interests represented and remain active, interested, and informed, also keeping a good level of documentation during the process. And just to finalize my participation, I just wanted to remark that we are doing this exercise mostly to add value to the ERP system that we are creating. The development of this standard will create a much valid and robust solution. We started with an idea that essentially solved the problem, and we should end with a product and service that works and bring economic incentive and value to the user, to the manufacturers, and to the society. So the manufacturers will have the possibility to develop and produce state-of-the-art products with potentially a reduction in R&D or production cost, will maintain a high level of competitiveness, reducing the amount of risk. Users and operators will have interoperability and compatible systems. They will get reliable and durable systems, and they will be able to use consistent user interfaces. But most important, the whole society will benefit of having a safer sea. Will have a easy ways to trade, and the products and services will be in accordance with any other regulations that are at the moment used. So pretty much that's all, and I know that Mario will dive deeper into these organizations. Okay.
Pablo, thank you. Thank you very much. That's a really good set the scene there on standards. Perhaps could you go back to your slide with the list of organizations, please?
Yes. Are you still seeing my screen?
Yes, we can.
Okay. Yep. So I'm now not on that slide. Is that...
No, can you go back?
Oh, sorry.
That's the one there. That one. I think this is a really good. On one page, a good list of organizations. There may be others, but they may come out. This would be good for the working groups to as a starting point for them. So thank you for putting that together so neatly. Thank you. And any questions for Pablo there on standardization and appointed bodies? Any comments or questions? Okay, so we'll move on now to an example of standardization at ETSI, and I'm delighted to welcome Mario Wolterfang from German Waterways. Mario is the senior radio engineer and manages the radar laboratory and looks at standards there within German Waterways, and obviously has a wealth of experience on radars and radar reflectors and the like. So we look forward to hearing the examples of standardization and how this has been within the ETSI. So Mario, over to you. Mary, I'm not hearing anything. Are you muted or?
Yes, sorry.
Okay, right, we
Mr.
can hear you and we can see your screen. Thank you.
Yeah. Thank you, Simon. Thank you, Mr. Chairman. Yes, my presentation is about standardization of radar, RACON, and ERPS. Well, I think a lot of things have already been addressed. So just in short, why is there a need for standardization? Standardization of devices ensure interoperability. It guarantees minimum performance and minimum requirements for a device. It ensures safe and secure operation. It ensures protection of privacy and also the coexistence with other devices of the same service, as well as coexistence with devices of other services.
Sorry, a small interruption. I cannot see the presentation mode. This is something else. I can see your slide, but there is lots of other information.
Okay, thank you, Kaizu.
Okay.
Mario,
yeah, sorry, I have to share my other screen. I have to do this monitor installation here, so might be I have chosen the wrong one. Thank you for this. Thank you very much.
Yes.
Well,
thank you, Kaizu.
I hope you can now see the full screen presentation.
Yes, we can now. Thank you.
Oh, thank you very much. Sorry for this. So warranty issues and legal certainty are, I think, a very important thing for manufacturers, and many, many more advantages. But no gain without pain. Standardization also comes with some downsides. The development of standards can be very time-consuming, it can be expensive, and is sometimes tricky and difficult. For a manufacturer, the compliance process and certification process of a device with a standard can also be time-consuming, it can be expensive, and it assumes appropriate process structures within the company, which may not be a problem for bigger companies, but for a garage company and garage firms, this might be a very challenging issue. Certification is a repeating task, so the certification of a device might expire after some time, or if a standard is revised, there might be also the need to recertificate a device to a certain standard. And also after any modification of device, the certification might become void. For those who develop a standard, they have to keep in mind that standardization of a product may limit the diversity of implementation options and may also hamper the innovation. So doing some standardization work also comes with a responsibility and keeping these things in mind so that that should not occur. The scope of ERPS regarding standardization. Well, ERPS is a system which have several parts. One part is a RACON, which with EPRS functionality is an eRACON. We have the ship on radar with the ERPS functionality becoming an eRadar. And the third part, not to forget, is the radio link between both. There are even more things to be considered, for example, the P&D unit, but this is not the scope of my presentation for now. All these three domains are subject or potential subjects to standardization. There are different types of standards. First, there are legal requirements, carriage requirements, and regulations. Then there are performance standards and performance requirements, resulting in test standards. There are radio link standards and implementation guidelines. And on a regional level, we have other standards like harmonized standards. All these types of standards have to be considered. Now I come to the standardization bodies. We have the big standardization bodies with global, as a global players like IMO. IMO is the International Maritime Organization, and IMO issues global regulations and carriage requirements for onboard devices, like SOLAS. For us, it is in Chapter 5 is of importance, safety of navigation. IMO issues also global performance requirements for services. For example, the resolution A615, which deals with radar, beacons, and transponders. But also IMO has performance standards for radar, ship-on radar, A222, for example, or 278, which is about symbols for controls on marine navigational radar equipment. And there's another area. IMO also issues global performance standards, like minimum requirements for marine services and devices, like the resolution MSC 192, which is about the revised performance standards for radar equipment. And also I want to mention here MSC 191, which is about the presentation of navigation-related information on ship-on navigational systems, on displays. So IMO certainly is of very high importance if you look to standards. Another well-known standardization body, I think that's clear, it's the International Association of Marine Aids to Navigation and Lighthouse Authority, IALA, certainly. And IALA issues 3 types of standards. It issues the global standards for marine aids to navigation. It issues global recommendations for marine aids to navigation, like the IALA recommendation R101 on marine radar beacons. And it issues global guidelines for marine aids to navigation, like the IALA guideline number 1010 on Recon range performance. Another important global player is International Telecommunication Unit, ITU. ITU issues global radio link standards, like in our field, the recommendation ITU RM 824, which gives technical parameters of radio beacons. But it also issues for the ship-on radar, for the S-band and the X-band, appropriate operational characteristics and technical parameters. In addition, ITU also issues the radio regulations, which are an important document in this field. And the last big global player I have identified in this field is the International Electrotechnical Commission, IEC. IEC now issues global test standards for devices, like the IEC 62288, which is about the presentation of navigation-related information on shipborne navigational displays. So they define tests, methods of testing, and define the required test results. And also for the shipborne radar, which are in compliance with SOLAS convention, gives the standard 62388 the appropriate performance requirements, methods of testing, and required test results. But not only for the radars in compliance with SOLAS convention, but also for the non-SOLAS radar equipment, like for pressure crafts or fishing craft. IEC is not active only in the field of developing test standards. IEC also defines global digital interfaces, like I think every one of us knows the IEC 61162 digital interface, also known as an NMEA interface, an NMEA standard. Besides these global acting bodies, we have regional acting bodies. In Europe, I think in our field, the most important institute is the European Telecommunications Standards Institute, ETSI. ETSI issues different types of standards. For us, it's important that they issue the so-called European standards, EN. A good example is EN 303676, which is about navigation radar used on inlet waterways. It is a performance standard for that. But what is very important also to know is that ETSI issues so-called regional harmonized standards. For example, for non-SOLAS radar equipment, but also for river radar equipment. And I think there are many, many more bodies which could be, which might be considered at least. There's Selenelec, it's a regional standardization body in Europe. We have the global player IEEE. Here, especially the 802 series might be of interest. We have certainly RTCM, IHO, CESNI, and many, many national acting standardization bodies. To summarize what we have in the field of RACON and radar, I think the legal requirements and regulations are issued by IMO, as well as the performance standards and performance requirements. The test standards are issued by IC, and the radio link standards by RTU. The implementation guidelines comes from IALA, and we have, at least for Europe, harmonized standards issued by ETSI, but there might be also some similar standards in other regions of the world. One slide and one word about CE marking in Europe. Marine equipment that is addressed by international requirements are implemented in the European Union by Directive 2014/19/EU, which is the Marine Equipment Directive, MED. So the manufacturer goes for a notified body that tests and certifies a device for compliance with performance standards, applying the appropriate test standard. And if the device is in compliance with all these requirements, it gets a wheel mark approval, and the housing is marked with a label here with a wheel mark. But all other radio equipment, really all other radio equipment, have to be in compliance with the Directive 2014/53/EU, which is a radio equipment directive. Here, a manufacturer can do some sort of a self-declaration on basis of so-called harmonized standards. If no harmonized standard is available, he can also, it's open for him to go for a notified body and do a similar procedure as for the MED. But this certainly introduces additional costs for the manufacturer. But it's an option that should be kept in mind. RED comprises not only, more or less, not even with performance standard. It addresses EMC, the electromagnetic compatibility. It is about efficiency use of spectrum. It's about cybersecurity, privacy, and so on and so on. And if the device fulfill all these requirements, then a CE marking or CE label can be pressed or put on the housing, and then it is approved. So coming to my last slide, I tried to identify all standards with relation to radar and RACON so far. And I think what we have to do is now to figure out which of these standards perhaps already cover eRACON or eRadar, which of these standards have to be amended so that eRACON and eRadar is also addressed. At least I think that could be a good starting point for this work that have to be done. Thank you very much for your attention.
Mario, thank you. That was really interesting on the, and we have an animated graphic at the end. This is very impressive. Well done. A really interesting summary of the different organizations and the detail of the standards currently available, and how they may need to be, some we could incorporate into the ERPS, others will need to be adjusted. So thank you very much. Any questions for Mario on the topic of standardization? Okay, thank you, Mario. I shall take over the screen now.
Yeah, thank you.
Can you hang on 1 second, guys? Sorry about that, a small issue this end. Okay, I think this is the slide, and you should be seeing, can you see the slide there? Jaime, can you can, Jaime, thank you.
Yes, we can see.
Thank you, Jaime. So just a quick look at the roadmap now. This is a bit of a pin on the map, really. But by the end of this workshop, we hope to put some detail on that. But here's some of the challenges and I've put an analogy here that the development of the smartphone, 30 years ago, many of us would have had a analog mobile phone. And we look at it now and it's developed into a fantastically powerful computer. But there were 6 billion potential users, the whole population. Some people have 2 phones. And what we're developing here is a maritime system, potentially 75,000 customers, for ships on their radars, maybe more. And what is the incentive to invest in this? Particularly when there is a very good system at the minute on GNSS to give us PNT. So, and there are various contenders for resilient PNT and GNSS backup systems. And this ERPS is one of them, but it is one that has been proven and is definitely viable. But there's a long road ahead to persuade people to invest in it, as well as to invest in the technology to develop it. So here we see the steps to development. Obviously, we need to identify the standards. That's what we're doing over the next 2 days. We need to promote the value of this as a viable technology to the marine community. Then we need to develop the standards with further trials and test standards. And as these go along, we would expect to see improvements in accuracy and technology as the system matures. And then maybe we'll get some early adopters would decide to pick it up for reasons of security rather than reasons of backup. Then ideally we go for IMO approval, potential mandated carriage. Then it's adoption by ATON authorities and certain ships. So we're just going to look at some of these as we go through. This is what we're doing here, doing this next 2 days. And we need to get the standards bodies to talk about this. But it can take a year or 2 years just to get this on their agendas. So this is a long road, and but hopefully it'll be an interesting one. But there's going to be some challenges ahead, unquestionably. But then we want to, like the smartphone, there were lots of people clamoring for the next product, the next bit of technology development. So we need to promote the value of this to the marine community. As we've discussed, Raycon and radar manufacturers, ship owners, and ATON authorities to buy it. Because if they're not interested in buying it, it's not going to be a viable product to invest in. We've got to identify the standards, as we've been discussing, and there's going to be further trials, which we hope will bring development of the technology. And then we do our test and performance standards. And again, this is all along the long road of it. And accuracy, we saw the accuracy in the slide that Paul put up earlier on. IMO require 10-meter accuracy. This is a backup system, so it doesn't have to have the exact performance as the GNSS. But we hope that as technology develops, that this will become more and more accurate. And then at some point, we would need IMO approval, because if it doesn't get mandated carriage, it becomes an optional extra for certain types of ship. If it's mandated, obviously it will become a requirement as a backup, and it will then be adopted. But it could be that early adopters could be the niche users like the military or survey or national infrastructure, maybe ferries, where governments are concerned about loss of GNSS and the loss of national infrastructure that would bring, and therefore may purchase this as a regional or local PNT facility. And then finally, I mean, if it's mandated, it's going to be easy, but if it isn't, this is down to, you know, persuading ATOL authorities to invest in extra raycons along the coast. Every 30 miles or more if we want two, you know, if we want two raycons to give us a fix. But, you know, they are currently expensive. Maybe with higher volume production, they will be cheaper. But again, this will be the result of a risk assessment from the, you know, volume of traffic and degree of risk that would dictate whether or not that investment was supported. And finally, timescales. Well, these are unknown and will depend upon you know, political, financial, and risk appetite. They're the ones that are going to define how quickly this progresses. I've put down 15 years, but I'm hoping that by the end of these 2 or 3 days, we will have a clearer view of the paths along the road, and maybe we can get a nice sort of proper roadmap, fishbone diagram with the various components and potential timescales for that. So a quick look at timescale at the how am I sharing here? A quick look at the roadmap, and but we hope to develop that as we go along through the next few days. Now we come to questions. We've got a question and answer session now, a little bit ahead of time, about 8 minutes ahead of time. Do we have any questions so far on what has been said? We have technical experts on the screen. Any questions from anybody? Michel Hopper.
Yes, good morning, everybody. My question will be, you mentioned recently that there might be a range of about 30 nautical miles when it comes to raycon and the range it could be used. So my question to Paul or the others who did already some trials, so what was the experience in the trials you made, and could you shortly reflect what do you think is a realistic range of such a service? Thank you.
Good question, Michael. Thank you. The trials in Denmark and the UK, I believe, went out to 20 nautical miles, 15 anyway. The trials in Singapore were much closer. Singapore is much smaller. The test area was much smaller. It depends on the range of the raycon, the detection range of the raycon to the radar. That's always been the case, and that won't change. So a more powerful radar will be seen at a longer distance. The return path is never a problem. Raycons are actually very loud. They transmit at very high power compared to reflected signal. So it's almost never an issue where the radar cannot receive the raycon. With solid state radars operating at lower output power, that becomes a problem. We saw in trials with solid state radars that the ranges. Somebody has their microphone on. Please turn it off. Thank you. We found that ranges petered out at about, well, 5 to 10 miles would be a good range for solid state radars now. Keep in mind that the Raycons weren't designed to use the solid state radars. One of the issues that we have with the radar, with Raycons, is getting the sensitivity because of the very wide band of available channels within the radar. So that's something that needs to be worked out with the radar manufacturers. How are we going to do this? How are we going to maintain compatibility between Raycons and radars with solid state radars? Because people are going to ask for the solid state radar. They're going to ask for the performance at X-band. And the only thing preventing that from happening right now is the IMO saying that X-band has to be compatible with Raycons. But there's nothing really that says what that means. It's just doing what we've been doing for the last 40 years is really the standard there. So this is why I think it's important in this workshop to address that issue, that in order to be fully usable, we have to maintain basic radar and Raycon compatibility with solid state radars and how we do that. And that would help then bring our ranges back to something really useful like 30 miles. Thanks, Mike.
Thank you, Paul.
Yeah, thank you, Paul, for that. Christian Denker, I saw we have a hand up there. Christian.
Yes, so hello to everybody, and thanks for the nice talks till now. So my name is Christian Denker. I'm working at the IALA University in Germany, and it's very good to have a PNT and resilient backup here with the ERPS system. And I wanted just to throw up again the point of resilience here. I was thinking about, as it was right now, I think not directly mentioned in the scope, how about the administration of such e-Raycons? Because we heard it will be static on static poles or something like that in the water, but they also may be hit or taken offline, and also just as GNSS, there's the possibility of spoofing. So how the question, I think, should also be thinking about monitoring position of radar beacons. So, and then also having like the ability to turn them off if yeah, maybe relocation is done, and how to do that, all authentication and validity check on the data transmitted, I think. So thank you.
Christian, that's a very interesting point, and with AIS that came in, you know, when it initially started, then we had monitoring stations, and you can monitor them remotely. I think that's all technically possible, and I can envisage that there will be some integrity and monitoring stations scattered around to verify performance of these. Yeah, thank you, Christian. Thank you. So we have a question here from Yang Jian. Is that over to you, please?
Yeah, one question. Just now I got the information from the slide that the Raycon should be placed every 30 nautical miles. So how do you get the data that the Raycon should be placed every 30 nautical miles? So I want to know this information.
Okay, yes, that was an approximate assessment that if the Raycon had a 15 to 20 mile range, you would need one every 30 miles to pick one up as a minimum, and it was purely that. But clearly, in some coast lines, you would need many more, and maybe on other areas you would not. So I think it would be down to a risk assessment as to how close that you decided to place them. So that is not an absolute figure at all. Okay, we've come to, we're 10 minutes ahead of time. That's not too bad. So I suggest we, if there's no more questions, I can't see any more. I suggest we try to hold to the program and go and make ourselves a cup of tea and return back at 12 o'clock in 20 minutes. And then Michelle Hopper and Ronan Boyle will share the next session, session 2, looking at a plenary brainstorm, and then we will split into working groups. Michelle and Ronan, is that okay with you? If we'll all be back online for 19 minutes time at 12 o'clock UTC.
Sounds reasonable to me. Yes.
Okay.
Yes.
Thanks, Michelle.
Thank you, Simon. Yep.
Thanks, Ronan. Okay, everybody. So I guess we leave our screens open and go and have a brew up and a freshen up, and see you back in 20 minutes. Thank you.
Thank you. Bye. Yeah. Hi.
Well done, Michelle.
So, hello, Simon.
Hi, Michelle.
Shall we already move on, or
I think
so.
I think yeah, we're 12 o'clock, and I think we'll see how this session goes. Yeah, let me know if you would like me to help at all. So.
Okay.
Okay, Michelle, do you want to start off this session too? Are you happy to do that? Yeah. Michelle, you're muted, I think.
Sorry. Yeah, thanks. And I think this next session is a brainstorming session which we will have in plenary. And the idea mainly is that we are splitting afterwards a group into working groups and to deal with the various matters which are also giving in the program. And so I like to share my screen, and I hope that will work. So you should see the slide of this brainstorming session.
Yes, we can see that. Thank you.
Okay, thanks. Simon. I think in the program this morning and the various presentations, we have heard a lot of what are the standardization bodies and what is their main task. And I think we have heard about 3 areas of standardization. And I think this is, when I have noted that correctly, is when we're looking to the included devices, the onboard device as the e-radar, and we have the installations of the e-Raycon, and there was also mentioned the on-air spectrum. And so my question to all is that complete, or do we have any other ideas of what parts might be also needed to standardize? Is there any feedback from the floor? Okay. I see a hand raised from Mario. Mario?
Thank you, Michael. As I mentioned in my presentation before, I think we have at least another domain which we have to consider, which is related to PNT itself. If you have a position calculated in the e-radar, there is a need to provide this information in any kind to the PNT unit. And therefore, I think there is another interface we have to take a look at, and that is the output of the interface of the e-radar.
I think you are completely right. So I will just put that then again here as another bubble, so to say, and say, yeah, PNT, or in general, I would say it deals with the interfacing issue. I'm not sure how many people are involved in that process about the PNT domain itself. So there were a lot of developments over the last year, and one of them was the introduction of a so-called multi-system radio navigation receiver. And I could also see the idea that the position developed from the e-Raycon or e-radar might go into such a multi-system radio navigation receiver. Do we have any other comments on that? Okay, Mario?
Perhaps to precise my proposal a little bit more, I think there are some options what kind of information we could provide on such an interface. For example, we could provide a complete position, an absolute position, but we could also provide some range. We could provide some perhaps some information about accuracy, availability, and so on, and perhaps even if we could come to an estimation of the error, it could also be worth to be provided on such an interface. That is what I meant. It's not just what protocol to use. I think we have to figure out what information is worth to provide on such an interface. Thank you.
Okay, thanks. Simon, you also had your hands up.
Yes, so just on a different topic, and I don't want to get as we say, muddy the waters, add in things that are peripheral, but should we be looking at a monitoring standard so that we discussed earlier how we have these e-Raycons, but do we have some monitoring and integrity stations nearby which feed back to the authority that it is not being jammed or that it is working correctly? Because at the moment, our Raycons only just say it's on. It doesn't say I'm sending out a correct pulse. Is that too detailed at this stage. I think is your decision.
Yeah, thanks, Simon. I think that's a valid point, and I just, I mean, the idea is now just to collect some ideas and thoughts, and then we may discuss that later in the working groups what to do with it. So, yeah, I think monitoring could be one of the elements we have to look for, and so. I mean, when it comes to monitoring, in my mind, there's also something which could be a use case in respect to the e-radar and rate. That would be if we're just receiving one e-raycon, so that could be also used for monitoring the PNT algorithms. So just having that independent source, even if there's just one range, could already set up kind of a monitoring. So that could be a use case. So maybe Paul, I'm not sure, is that something, or yeah, more or less this is a question to all of you. Is that a valuable or valuable use case which should also be addressed somehow?
Hi, Michael, this is Paul. Yeah, integrity monitoring is a good idea. I hadn't really considered it very much till today. Good point. Very good point. Thank you.
So any other ideas of Simon?
Yeah, it's me again. You need to mute me if I speak too much, Michel.
No.
Are we looking to send a time stamp on the radar paint, on the radar pulse? Sorry, on the Raycon pulse. You know, it is a land-based. It may have access to time. It may not, but if it does, is that for consideration or is that not?
Maybe I'm not sure, Paul or any other who did already some trials on that. What do you think about that idea?
We can certainly put it on the list. Yes.
Yeah.
Timestamp.
If you allow me, I just would like to take some notes, and I think Simon, if I understand you correctly, it's so to say to add a timestamp. Is that right?
Yes, that was my thinking. We get time from the satellites. Obviously, we don't need a timestamp for the ERPS, but it may be an opportunity to send one out, or I don't know.
It could be a component of the integrity monitoring, actually.
Paul, if you could repeat the last sentence, please. I didn't really receive that well.
Oh, I'm sorry. Yeah, I would think the timestamp could be part of the integrity monitoring. If you receive an old timestamp, then you know there's some integrity right there. Yeah, it's a good idea.
Then I see Christian, and I think before I also saw a hand from Kaizo, so I'm not sure about the order. So maybe ladies first, if you allow.
I'm waiting. Maybe Christian will mention what I was thinking to say. So I will stay on hold.
So you can, okay. So then on the E-Raycon, there's a question on configuration. So if we monitor and we figure out that the E-Raycon has some error or something, we want to take it off, or maybe program in a new position or something like that. And this has to be somehow secure. So maybe I'm just brainstorming on maybe some VTS is going to like input via a secure channel, which these configuration options. Is this something?
So you see what I was typing. So if you agree to that, then let's add that point. Yeah. Well, thanks. Then Kaizu, would you like to add anything else?
Yes, it was about the authentication that I think that Christian mentioned earlier.
Okay.
So that might be added somewhere.
Okay, thanks. Then there's a comment from Mario.
Yeah, thank you, Michael. I tried to listen well in the session this morning, and I made some notes of topics that we have already identified. So one question was about the calibration of the device or need of standardization, because certainly the any RACON needs some processing time, resulting in an additional error. So I think there might be the need of calibration of device or standardization of this issue. Then I have, okay. Then I have noted the question concerning if it should be only on X-band or S-band. Is it an S-band and X-band system, or shall it be restricted to X-band? That's another question that would arise this morning.
So that raised, to my opinion, a little bit the question if there are still some technical questions and issues which we need to clarify. So maybe technical clarifications. And then I would say I take that point on. Please correct me when I'm wrong. There was X versus S band. There was
the complete question concerning solid state radar.
Yes. And the question of calibration, is that a very special E-RACON one, or is that a technical, or should that be also handled under the technical details?
I think it's a technical, but also it's a question of what shall it be for the radio link. Maybe it may be possible to that not only the position is provided by the E-RACON, but perhaps also some calibration parameters. It's just an idea, but could be perhaps discussed in the workshop. Thank you.
Okay. I just take it first under the clarifications, if that is okay for you for the moment. Then I a little bit lost the order of who was raising his hands. So I think it was Paul and Ronan. Maybe Paul first, if it is maybe a comment of one of the earlier issues.
Yeah, thank you, Michelle. Configuration, well, that's not the only thing that needs authentication. The signal itself needs authentication.
Okay.
So that's part of on the air spectrum.
You see that more under the so authentication, that is more something that you see under the spectrum issue. Is that right?
On the over the air, yeah. Yeah, it's you know, for instance, AIS is entirely unauthenticated. Anybody can spoof anybody anytime. If we authenticate our signal, it makes it more difficult to spoof.
Okay. So Ronan?
Hi, Michelle. Just a query on the configuration, and I think it was mentioned earlier by Paul in one of the presentations about the position of the eRaycon will be surveyed to that particular location. And I suppose a common practice with current Raycons is that they are, if they fail during operation, they are swapped out and the Morse character may be reprogrammed. But we would probably need some instructions to ensure that the position is reflected for the Raycon that's going in there, because that would seem to be central to its ability to generate the position of the vessel.
Yeah, I agree. So where do you think should that that point mostly go through to the eRaycon? Is it
Yes, I think in the eRaycon domain, we need some mechanism to ensure that it's serviced and maintained correctly, including replacements.
So ensure valid position, is that something which
Yes.
would take the point? Okay, thanks. Okay, maybe yeah, first I would like to have a look. Are there any other comments which are directly going to that discussion we had already? I don't see any hands so far. So yeah, maybe, yeah, sorry.
Sorry, something come back into my mind. What kind of radar will be addressed by this? Is it just SOLAS, also for the bigger vessels, or is it also addressed to, shall we also address the non-SOLAS radar equipment? Because if we go for these kind of radars, we have to address other standards than if we stick to the SOLAS compliant radar. So perhaps this could also be clarified in the workshop, if non-SOLAS radar should be addressed or not.
Who is going to answer that question?
Maybe we have to figure out. But I think, as I said,
Michelle, the workshop will answer that question.
Yeah. So I'm right to say it's more a point for the e-radar in that instance, because the SOLAS, yeah.
SOLAS versus non-SOLAS.
Okay. Yeah, okay, there's another hand up raised by Ellen Search.
Yes, for the eRaycon, the sensitivity. I think the sensitivity of every eRaycon should be standardized.
So that was sensitivity. Thanks. Any other comments? Seems to be not. Then, I mean, this is just a question which came into my mind when I'm so if I'm right, the idea is generally that we are providing the position of the e-Raycon by the modulation of the e-Raycon. So is it also possible solution, or could it be also possible to take a position which is stored in an almanac elsewhere? So if we have known positions and let's say a e-radar has a kind of an almanac, which is a digital stored into that device, would that also work? And is it an alternative? Omar?
Yeah, thank you. Yes, good morning, evening, afternoon, everybody. This is Omar from from IALA. Yes, indeed, I agree that an almanac could be an element, another part of the solution, if you will. It could also help in the in the authentication process, if you will. Could be useful in that case. So I would support that indeed.
Thank you, Omar. Paul, maybe a question back to you. Is that something which you had in mind already?
Yes, I was just going to bring it up when you brought it up, actually, and it was actually a part of the original thinking in the very beginning that we could have almanacs, and that this concept wouldn't only be the concept of aids to navigation identifying themselves in a more generic scope, such as visual aids, lights, with appropriate modulation of their signals. So an almanac and connectivity that the device is indeed connected and contactable through Internet of Things type of links, if you will, something like that. Yep.
Yeah, thank you, Omar. And I'm really not a radar expert, so the question is, does that also then is that also then a possible solution for typical or classical Raycons that could then also be included in such a system or not?
Yeah, surely all known objects can be a part of the almanac, and the way that you communicate with them. Is it an E-Raycon or not? That's a possibility. Basically, you have it in the chart. You have this type of information in the chart. Location and type of these things. The new thing is the almanac could be then shared or like something that can be obtained from the competent authority. And a certified copy, if you will, or as part of the authentication process. Yeah.
Okay, thanks. That sounds good. Mario, you have a comment on that?
Yes, I think it's a very interesting approach by using an almanac, but you have to consider that the processing in the radar is different. If I understand, the ERPS for now right is that the information is modulated in the first dash. If you do it on an almanac only, you have to process the complete answer of a Raycon, which gives the identification of the Raycon. So I think it's a very interesting approach, but it would result, I think, in a different way the e-radar have to process the information. But yeah, it certainly comes with a great advantage that you do not have to do any modification for the Raycon side, just for the radar side, and therefore I think it's at least worth to spend some thoughts on that. So I think it's very, from technical point of view, very interesting approach. Thank you.
Okay. So Paul, I think you have respond to this discussion.
Yes, one of the important features of the ERPS as presented so far is that the radar needs no pre-knowledge of the E-Raycon. No chart is necessary, no other information, no almanac is necessary for the system to work. Now, when we get to authentication, how do you distribute the keys? Now, all of a sudden, you're implying an almanac, and that may change everything. But the simple system that we demonstrated, there was no almanac needed because there was no information that the radar could not get from the Raycon. And in this case, it was just position and identification. So we need to think very carefully about an almanac. Where's the information coming from? if you want to include data from one Raycon on the operation of other Raycons. So you really want to do that, because that's a lot of bandwidth and there isn't much available. You know, things like that. So I think that's something that the workshop should consider, is if some sort of an almanac is required. Yeah, that's good. Good point. Thank you.
Yeah, thank you, Paul. So I see still a hand up from Mario. Is that an old hand or a new hand? Mario, you are unmuted if you would like to say something.
Yeah, I've already under my hand. Sorry.
Okay. Any other comments to the bubbles which we have already on the screen? Are they complete? Is there anything missing? Okay, then to my opinion, I would like just to come a little bit of a short moment back to the interfacing and portrayal issue. So as mentioned before, we have some standards prepared which are related to the PNT equipment, which is the multi-system radio navigation receiver, and also the I think it's the 401 95. This is a performance standard for the multi-system radio navigation receiver, and then there's a data processing guideline. So the idea is really to have a variety of various inputs, which could be the GNSS, which could be terrestrial information, that could be augmentation, and so I would like to hear your comments about that. Do you think this is a good idea to have, let's say, the information gathered within the e-radar given to a kind of a PNT device on the bridge, which is doing then the PNT stuff, looking for the GNSSs and the terrestrial backups or other backups, and then providing, let's say, a solid position information to the bridge system at all. Any comments on that? No comments? So then, yeah, Neil?
Hello, Michelle. I was just looking at the IMO GSIS, Global Integrated Shipping Information System page. I'm just wondering if we can get IMO approval, there may be scope to include this subject within a dedicated page within GSIS. That's all. Thank you.
Thank you. And I mean, the other idea is then where to portrayal or where to provide that position information to. Are there any other options instead of giving that to the PNT part of the bridge? Okay. Okay, then I think for the time being, let's take that away for a first result out of the brainstorming session. So if there are no other ideas, comments for the time being, then I would like to move, let's say, to what was also raised and introduced from Simon this morning. How to develop, what is the vision which we should have with respect to the roadmap, and so any ideas on that? I think Simon, when I'm right, you mentioned a time span of 15 years. So
yeah, I did. I mean, it's that was just a finger in the air because it is an unknown, but I'm happy to take a view.
Yeah. So any points which you have in mind which we should address when it comes to developing a roadmap that we could give back to one of the working groups, Ronan?
Just that we should probably take into account the World Radio Congress dates 2023 and 2027. I believe the 2023 is already full as per the agenda, but that probably needs confirmation. So anything that we want to input probably needs to go to 2027.
Yeah, that would address mainly the ITU, if I'm right.
Yes.
Yeah. Is there anything which we have to take into account, or do we have someone within this group who is familiar with the time spans of IMO? Ronan, you have still your hands up. Maybe you have an answer also on that.
Apologies, no, I don't.
Okay. To my opinion, what could be done, I'm not sure, but I think what was also in that presentation from Simon was that we have to address somehow, make IMO aware about such a development, and so the question is, what would be the best way to do it, to get such things on the agenda of IMO? Do we have any answers on that? What could be the best? Yeah, Kaizo.
I don't know. I probably don't have any answers, but was thinking that when IMO is informed, maybe it would be nice to identify the like we had in one of the presentations, identify the performance standards and other documentation from IMO that would need to be somehow updated, just to give an idea of the workload. Because I guess that in IMO they are afraid of getting much additional work in their agenda.
Yeah, I agree. I mean, we more or less experience that also when it comes to another solution, the AMOD we are working on, and so it's very difficult due to that special situation also issued to the COVID, that yeah, they don't like to add more work items on their agenda. But anyhow, I think if there's a large international interest and support, then I think that could be done. So any other yeah, standardization organizations, bodies which we need to address? Is there some other knowledge in that group? What is important maybe to note? Otherwise, we have then to go into the details when it comes then to the work in the working groups. But this is just to gather all information we have on board for this plenary session, and then we could take that away, and yeah, all the other working groups could then have a deeper look on that. So there's Paul again. Yeah, please.
Thank you. IMO is going to be the key of everything. Nobody's going to do it if IMO. I don't think they'll forbid it. It's just that they won't allow it if they don't like it. Getting IMO at least interested in it and saying, getting at least to the point where they want more information from us would probably be a win. I think we need to really focus on IMO, especially in that working group 2. How do we get IMO's attention? How many states do we think would be needed on that request to forward that to IMO? Yeah, that's going to be very key. Because without IMO at least interested in it, none of the other standardization will actually finish, really, if we think about it that way. So while the technical bits are fun to work on, the real work here, I think, is going to be IMO. Yes, thank you.
Thank you, Paul. And I'm not sure if I mean that when we are going really to address that this E-RACON or EPRS is something which contribute yeah, to the resilience of PNT, which is already some of the risk control options, and so it's really something which is in line with the policy of the IMO, to my opinion. And if we could address that this is more or less part on already existing work which we had on the PNT domain, and this more or less already covered within that multi-system radio navigation receiver, that could, to my opinion, also accelerate some standardization issues at IMO. But this, yeah, I'm not sure. Okay, any other thoughts? Okay, then I save that for the moment, and just looking, yeah, just I would like to cover maybe some points when it comes to draft liaison notes. Maybe as one question to Jaime. I think do we have templates maybe for that?
Yes, we have the template for the draft liaison notes, and as well the report template I have sent 1 hour ago.
Okay, so that would be maybe then a good idea to forward that to the working groups, so that they maybe could use then already some kind of a template when they are going to draft liaison notes to the various bodies. Any other thoughts with respect to the draft liaison notes or cover sheets? Paul?
Yes, I had an email this morning from Alan Grant, who will be with us tomorrow. He suggests that we also be sure that the body of the liaison note includes a paragraph or a pointer to an annex on a discussion of what ERPS, what it's for, and why it's a good thing.
Okay.
So include intro to ERPS, I guess would be the words here.
Yeah, I think it's a good idea, especially when we are addressing bodies which are not already informed about that.
Yes. He had a second point,
yeah,
which is why the body we're writing to should be interested in this. It might not be obvious to the group why they ought to take this up, so we need to maybe gently and politely tell them why it's their problem.
Would that take that point, Paul?
Yes, that's the point. And the last point is what it is we expect them to do. What are we asking for?
Okay. Any other points, Simon?
Yeah, thank you, Michelle. The all liaison notes will need to go back through the committee to the IALA Council, and obviously, and then they are approved before they go out to external bodies. And I just maybe not right this minute because time is running away, but perhaps Francis and Omar, I need to consider. You know, have we sold this concept to the council, to the IALA Council? They've seen it in the work plan, but you know, this has a big impact into the future, so they need to be familiar with it and support it in the very first instance. I don't know. I think maybe we could hear from Omar later on this about how we might approach that. Thank you.
Yeah, if I may, then the first step in this would be to report nicely from this workshop to make councillors aware of this concept in general, and from there to report to council about progress, etc. So they won't be surprised when the liaison notes come about after they've been through the committees. So.
Yeah. Okay. Thanks. Any other ideas, topics to be included under the headline of the liaison notes or cover sheets? Okay. Then I think we are almost there. Yeah, I just highlighted what was originally planned within the working groups as set it laid out with this workshop program. And so the question, to my opinion, is now how to split that group. So the idea is then to meet tomorrow morning to continue in the working groups. And one working group will then be shared by Ellen, and the other will be shared by me. And so having these various topics given here, my first question would be, is there any topic which you would like to see in addition to what was already drafted? So that seems not to be the case. Then another question. Yeah, Simon?
Sorry, it's me again. Thinking back as to how AIS was devised, developed, and then rolled out, and lots of other functionality has then emerged in the AIS use. We don't, obviously we are keen that this happens, so we don't want to spend 15 years deciding what it might do, but is it worth considering complementary functionality that may be available on this system, such as a timestamp? Or do we want to say, no, forget that, just keep it simple as a basic, reliable PNT system? So is other functionality a topic to consider or not? I don't know whether Paul has a view on that.
Simon, when I allow to go back, so maybe my personal feeling, but this is just my personal view on that, is that we, beside that working group schedule which we currently have, that there is still some technical clarifications which should be discussed in one of the working groups. So maybe it would be a good idea to have this technical clarification somehow reflected in the working program, either the working group 1 or 2. I think maybe 1 is a little bit closer to the technical domain, so that could be an additional point which we should add on the terms of references for the WG1 group, and then that could also take this question in it, because I think there's still some discussion needed for the technical clarification. What do you think?
Yeah, that sounds good.
I agree.
Omar?
Yes, just to follow up on that, I agree with you, Simon, that the development of AIS could have been better in the rear mirror, watching through the rear mirror, in terms of the use cases that came about later. So we should indeed also think about that in this process, but in order to keep our focus in this workshop, we should stick to what we have planned and not widen the scope too much, because we have ample time to think about all these aspects. Basically, I think Paul would agree.
Yeah, Paul?
Yes, I do agree. Yeah, the BDES is correcting the early problems we had with AIS trying to use as a telephone system. For many, I don't know, there's not much bandwidth available here, far less than with AIS. While it might be superficially attractive to send other messages, if you will, there's really no room for it, and there's no point to it because we have other communication media available. There's you know, BDS, there's AIS, there's cell phone, LTE, there's satellite connections. There's all kinds of ways to transmit information to the ship that I don't think we should consider in this workshop. We should not consider anything other than the point at hand. How do we provide the basic service, and let the future think about if there's other services that could be provided on the same medium. Thanks.
Okay, thank you. And we have another comment from Peter.
Yes, I would agree with Paul entirely. I think that if there is a selling point for this system, is that it is relatively inexpensive and relatively simple to install. And the more we try and complicate it by adding functions that require a communications medium, then we both make it less likely that it will be installed, and we also increase the cyber risk and increase the complexity of actually ensuring the data integrity of what we're trying to provide.
Yeah, thanks, Peter. I think that is a valid point as well. I think, yeah, for the time being, when I'm looking back to yeah, the terms of references for the working groups, so I think they are There's a lot to do in that working groups, and I think what we need to do in the remaining time we have, only 4 minutes. So is there any direct point which you would like to address for the terms of references so far? Seems to be not. Thanks. Then I think the way of splitting the group, I think best is if we just have a feeling of how many people are going to the working group 1 of the technical standard issues, and maybe the easiest way is just the people are interested in attending on that working group, if they could show their hands, raise their hand up, so that we could quickly count. So it seems to stabilize somehow with 11. Pardon?
Yes, I count 11 as well.
Yeah, okay. So 11. So if you could lower your hands, and then I would like to ask for the people going to the other group, working group 2. So that seems to be really balanced with 10. Okay, and it seems that all the others are not yet really quite sure where to go. So yeah, you are invited to visit tomorrow one of the groups, and then I would like to give back maybe the word to Simon for final word.
Thank you, Michelle, and nicely run there. Thank you. Some good feedback coming in, really exciting topic, and you can tell your grandchildren that you were here at the start of this, and I think it's going to be an interesting topic to work on. So thank you very much. We're right on time, and so tomorrow morning, if you go onto the IALA link for either working group 1 or working group 2, so they're 2 separate links for the 2 separate working groups, and that we are doing that all day tomorrow, and then on the Wednesday we will regroup into a plenary again. So thank you for your contribution and for your time, and I look forward to seeing you tomorrow. Is there any comments from anybody? Any questions about tomorrow and the future there? We have a hand up, but it could be an old hand from Andreas. Okay, no questions. So thank you very much. We will say goodbye now, and we look forward to seeing you all tomorrow. Thank you, Michelle, for covering that one. Thank you.
Goodbye. Thank you all.
See you tomorrow. Bye.
Thank you.
Bye.
Thank you. Bye now.
Thanks.
Thank you. Bye.